The final concept I want to cover is technically from more section 6.3 than 6.4, but I just want to talk a little bit about some more applications we can do with vectors. As I've been saying the whole time, a lot of the applications have to do with physics. That's just more because of my background. I'm not sure what other examples there are in other sciences or other situations, but there are quite a few in physics. So that's what we're going to look at today. So the first one I want to talk about is basically forces. So let's just say that there are three forces acting on an object. And we're just going to say in the xy plane here. And their forces are, they are 70, 40, and 60 with angles. Let's go with 330 degrees, 45 degrees, and 135 degrees, respectively. Meaning that the 330 goes with 70, the 45 with the 40, etc. So what I'm curious about is what is the resultant force, magnitude, and direction. Basically, where is this object going to go and how much force is on it in that direction? So a good way to start these problems is actually to draw a diagram. So let's just say here's my object, it's a square of some sort, and let's go ahead and put a coordinate plane on it. Now I have three forces which I'll call F1, F2, and F3. F1 goes around 330 degrees, so it ends up about here. F1, and its force is 70. All of these are in pounds. Force 2 is 40 degrees, which let's just say is maybe about here. And it is, 45 degrees, and its power is 40. So that's about a 45 degree angle. This first one's about 330. The last one is 135 degrees, so let's go ahead and do that one over here. And it has 60, so 135 roughly should be about there. Okay, so here's my diagram. This is F3, and then this over here is F2. Now, in order to figure out the resultant force, what we really need to do is calculate what would happen if I added them all together. F1 plus F2 plus F3 will give me that final total force. If I just add them up, it kind of makes sense, right? Now the trouble is we don't know how to add these. I have some sort of number with an angle, but I don't actually have their component forms. So step one, after we write down that formula, is going to be to convert all forces to component form. And what that means is we have to figure out basically what this is. F1 is going to be a magnitude of 70. Its x component is cosine of 330 degrees times 70, and its y component is the same but sine. And then F2 is going to be, 40 times cosine of 45 degrees, sine of 45 degrees. And then F3 is going to be 60 times cosine of 135 and then sine of 135. So what this means is when we add them all up, if I take f1 plus f2 plus f3, I don't actually know what the components are yet, but I do know that the x component is going to be 70 times cosine of 330 plus 40 times cosine of 45 degrees plus 60 times cosine of 135 degrees. You could figure each of those out individually, or you could just plug all of that into the calculator, which is what I did. Calculator. And then the y component is going to be similar, except it'll be sine. So 70 sine of 330 plus 40 times cosine of 45 plus 60 times cosine of 135. Again, I'm just going to plug all that into the calculator. So I get that this is approximately 46.5 and 35.7. If your answer is different, please let me know. Might just be a calculator issue. You might be in radians mode instead of degrees, or maybe even I did something a little bit wrong, but I think that's correct. Okay, so I have that. This is the component form of the force. Now I have to find the magnitude and direction of this. Going back to 6.3, to find the magnitude of the force, we're going to just take the square root of 46.5 squared. Now I'm not using the rounded version when I do this on the calculator, but it does help when writing it down to use a rounded version. So I get that this is approximately 58.6 pounds. So that is the force, or the magnitude of the force is 58.6 pounds. The direction, we would take tangent of theta equals my y component over my x component. And then solving for theta, we should get about 52.5 degrees. Which should kind of make sense if we look back at the diagram. So if you look at all of these and try to sort of add them together, it would kind of look something like this. We have 40 for F2. F1 is a little bit larger, so if I add F1, it's going to maybe be over here. And then F3 kind of goes back this way. So my total resultant force looks like it might be about there. So that does sort of look like what we'd expect. 52.5 degrees looks like it's about right. It's in quadrant 1 at least, and it's going to be a bit longer than, say, force 2, but not as long as force 1 maybe. That's a little bit harder to see from this. Okay, so there's the final answer.